thank you.
Okay, guys, thank you very much for joining us. So I'll try not to take up too much of your time, and Jill can keep me right in the time, because I know that I can tend to get a bit bought in and passionate about things and just and keep talking. So hopefully I'll try and keep it short and concise and allow plenty of time for questions as well. But as Jill said, if you have any questions at all, please do drop them in the question or comment section, and we can address them as well at the end, okay? So if you have any as you go along, just feel free to drop them in the questions. So this is about smart manufacturing systems, a master's held at the Magee campus. And as Jill says, I'm Emmett, so I'm the course director. If you have any questions after this, or if you have anything that you want to just run by me, or queries about the course in any way at all, please do contact me. Feel free to touch base and contact me, okay? So my contact details are on the screen there at the moment. Unfortunately, I'm working from home at the minute, so where that is my office, on the Magee campus, I'm not typically in it due to the current circumstances, but you can still get me on my telephone number and email, okay? Email is probably best. So just about the course then, what I would like to do is just open up, for those particularly who have never studied in Ulster, or maybe have studied in Ulster and you're just considering continuing that study, which is brilliant. I just wanted to highlight what we take a lot of pride in and what we're very passionate about upholding is our teaching excellence, okay? So, and that's not just me saying that, because of course people would say, oh, well, you have to say that, don't you? But the bottom line is the feedback from students is also similar as well. If you look there, 94% satisfaction across the National Student Survey. That's from students telling us that we're doing a good job. That's one of the highest in the UK for engineering and again for computing. So we really do take pride in our teaching, and we really do strive to make sure that students get a full all-round experience of university, not just gain knowledge, but enjoy their course and be able to relate that to applications for industry or for whatever career they're pursuing. We like to have friendly open door policy. That still remains the same. I know it might be a physical open door at the minute, but I'm still contactable via Skype, and I touch base with students on a regular basis. And that goes above and beyond the course as well. If there's anything else the student's struggling with, perhaps an international student trying to settle, or you've moved away from home for the first time and you're living in the city trying to do your course and stuff, and you have other things and other concerns, by all means, we have an open door policy. Just drop us an email and call in and see us, because it's really, really important to us that you're enjoying your time here and that you're happy and you're well, and because that comes across in your study. So drop us an email. We have that open door policy. I'm not a counsellor or anything like that. I'm not claiming to be, but if I can't help you there and then, I will guide you in the right direction and signpost you to our fantastic facilities that are available across all campuses in terms of student support. So definitely we take a lot of pride in that. We have state-of-the-art computing facilities which are accessible 24/7. Again, due to the current circumstances, that may vary. Obviously, we've no students coming on campus at the moment. But we are working hard to get remote access to those lab access PCs as well, so that the facilities are still available. Okay, we like to see you, our students, as partners and co-creators rather than someone that's just here to learn. There's nothing better than me working with someone to develop something new or investigate something new within smart manufacturing, or try a new application of data learning or data mining or robotics or something like that within an industry that you're familiar with. So for me, it's more a partner relationship or a co-creator to create new things and learn strongly from those things, rather than a teacher-student type relationship. That's not what we strive towards. And anyone that has been taught with me in the past will probably agree with me. I hope will agree with me on that anyway. We have a number of staff awards. I highlight just a few. Learning and Teaching Awards. We have Inspirational Teacher of the Year, Educator of the Year for Computing and Engineering, and a ream of awards throughout our coaching and teaching staff. So it's absolutely fantastic. We just want to drive that home, I suppose, highlight that before we start. At the minute, we have 3 postgraduate courses, industry ready within our school. The data science, which is taught in both Magee and Jordanstown. We have professional software development for those who are coming not from a computing type degree, not a perfectly aligned degree. Let's say it might be in a different area, but this master's allows you to come in and become proficient to a master's level in professional software development. So it's not a really popular master's. But the one that we're here to talk about today is the smart manufacturing systems. And this is a relatively new course. We've had a fantastic first year, absolutely brilliant feedback. We've actually been delighted with our feedback, and that's again from the students as well as our external examiner and industry partners, which has helped us strive to change the little bits of the course as well and just continue to improve that course, which I'll go through at the moment. As I say, I'm course director. So what I suppose preempts, what differs a master's from an undergraduate is that there's a large research aspect as well. So it goes above and beyond undergraduate. It goes towards the research aspect of industry, of different industries, maybe be it mechanical, manufacturing, even right through to medical, anywhere that we use big data, anything at all like that, we try and bring our research to life through the teaching, okay? And I just want to, I suppose, preempt what we teach with our research in the school. And we have a wealth of research within the school, from robotics to industrial robotics to brain mapping to BCI to embedded systems, right through mobile robotics, everything that we can think of really in terms of the area of computing and engineering that might be applicable. And why I'm raising this is that a lot of our lecturers, majority if not all, are research active. All the lecturers within this course are certainly research active, and they'll bring their research through into the teaching. So we will have research applications or research examples coming through, and why we use key tools that we're teaching in it. And it also opens the door for yourself to bring in ideas as well, maybe from an industry that you've worked in, maybe from a research project you've done, and it just allows that two-way relationship. So all of our teaching is very research informed and research led. So the course itself runs over 12 months, 1 calendar year, which is 3 semesters if you're doing it full time, or 24 months, which is 6 semesters if you're doing it part time. The 24 months is changeable, which I'll come in a little second if you are interested in the part-time route. But as I say, for full-time, it's not your standard undergraduate academic year where we have 2 semesters, it is 3 semesters. So it runs from September through to September, and that's an important differentiation and something to note. What we focus on, listen, modern manufacturing, guys, a growing industry, it's worldwide, it's continually challenging us as engineers or anyone with an engineering mindset. They start using technology and management systems in a different way. We have to strive towards Industry 4.0. At the moment, we're at about Industry 3.0. Some parts of Northern Ireland are still Industry 1.0, which I can come to next. But listen, we have to strive towards Industry 4.0. If we want to be competitive in a global market, then we need to be striving towards that. Okay, it's the future of automation. It's the future of data exchange, and it's driving us towards those smart factories that we so badly need. So this program is designed to, provide that advanced level of knowledge, the breadth and depth of engineers and management, and right through to such manufacturing environments. How can we be aware if they are globally competitive? So you'll gain a solid grounding, in mechanical processes, technologies fundamental to Industry 4.0. You'll have a greater understanding of all the methods and tools that are used, including the data science side of it, which may be a little bit scary for some engineers, and I appreciate that. I'm an engineer myself, and I had to teach myself coding before I did my master's, and I can understand that leap of faith and that concern. But as a logically minded person, it's not a big leap, and it is part of Industry 4.0. We are using data on a daily basis. So entry requirements, all this is online as well, but I'll just skip through it quickly so that we're aware of what is required. So what's required is a 2 or above in mechanical, electrical, computing engineering, or some form of related discipline. If you're unsure if your discipline is related or not, please do touch base, and I can advise that. Otherwise, a standard, an equivalent standard, 50% of a graduate diploma, graduate certificate, etc., postgraduate diploma or certificate. And there is also what's called an APEL route. Okay, so that's where if you're coming from industry. So if anyone's joined us today who maybe doesn't have a degree, they've been working in industry for a long time, and they're up to industry standard in this, we can conduct an interview, and based on your work experience, that's another route to enter as well. For what we do require is a written and spoken English. So that's a GCSE grade C or equivalent in English. Okay. For international students, that's an IELTS of 6 or above with no band below 5.5. Okay. So now that we've kind of went through the entry requirements and the overview, just to give a module overview, and we'll go through a little bit of these modules after this as well in a little bit more detail. I'm not detailing them all due to time constraints, but I pick out some of the modules and we'll look at them in a bit more detail. But if you're looking at a full-time approach to this course, as I said, it's 1 calendar year. So that will consist of 2 taught semesters. So the first 2 semesters are all taught modules, and your last semester, which runs over the summer, is a research project. So in semester 1, what you will do is advanced manufacturing and industrial robotics, and I'll have a look at that module in a little bit more detail in a second. You'll cover data science foundations, and this is new. So anyone that may have seen my previous presentation, this module has changed. The reason we changed it was feedback from students, feedback from industry, and feedback from our external examiner. So we felt that this would be a really valuable module for engineering students as a precursor or a build-in to your machine learning and data modeling in semester 2. Okay, so maybe just look at how we use data, how we import, export, and change data they suit. Okay, so how do we treat that data and get that data ready to be modeled or to learn something from it? So the foundations of data science is taught now in semester 1. And we're really passionate, and we really believe that's a great move. And student feedback when we explained what we were doing was very positive, and they agreed that it was a very good move. Guys, you'll have heard me say a few times now that we need to be aware if industry is globally competitive. Okay. Now, as engineers, we can always stand by our designs and stand by our methods and our processes and say that, yeah, of course they're world standard. Of course they are. But how do we put that in the business context? How do we make sure that industry and the industry we're working with is globally competitive? Okay. So we feel it's really important, particularly at master's level. And if you're looking at any form of management position in industry, it's required that you understand business terminology, understand business in the way that you can at least relate to the business side of the business of the industry, why we have to do things, and what's important. Okay, so we have a full module in there to bring engineers up to speed with the global business, and we put it in the context of smart manufacturing and in the context of global businesses. Okay, and how we can remain competitive and what does it mean to be competitive. And what I would mention is that module is taught fully online, even on normal circumstances. Okay, so the other ones would typically be in a classroom. Obviously, at the moment, they will be taught online until further notice of changes. And the business module, as I say, is typically online anyway. Okay, into semester 2, then you'll study smart factories with me. That's the module that I teach. And again, I'll go through a little bit of detail of these modules afterwards. You'll also study machine learning and data modeling. Now, again, guys, we have to use data, okay? Data and what we get from data is critical. Data is worth 0 unless we can get something from it, unless it makes sense to us as humans, unless it tells us key markers that we need to work on or we can improve or we can learn from, then we need to analyze that data, okay? And we can do that with the help of state-of-the-art machine learning techniques and data modeling. As I mentioned, we have a large research capacity in the school, and a lot of those research techniques come out in that module as well. And also in that semester, you'll study computer-aided engineering, CAE, and manufacturing at a master's level. So it would be, if anyone's sitting there that has done CAE in the past or manufacturing at an undergraduate, this is a step up, and it's how we would incorporate those techniques and skills and industry standards into a smart factory and into an Industry 4.0 driven factory. On the completion of your 2 taught semesters, there is an option at that point to exit, and you could exit with a postgraduate diploma award. Okay, so that's the exit award option at that point. What turns your postgraduate diploma into a master's in science is a research element. So your research element in semester 3 is a master's project. Okay, and what happens there is you're assigned a supervisor from one of our team who will guide you through a project. We would strive and kind of push for students to bring their own idea there, you know, an area that they want to work on. Maybe it's something you've worked on through in your modules and you really liked and you'd like to expand on it or take it to a new level of research. Maybe it's an application or a process or a data set from your company that you would like to analyze in more detail. really the option is yours, and what your supervisor will do is guide you through that project management process and ensure that it is at a master's level of the project. And that's worth 60 credit points. You'll note that that's worth the same as 3 of your individual modules. On successful completion of that, that's when you would graduate then with your Master's in Science of Smart Manufacturing Systems. Because I've mentioned a little bit of detail on all the modules there, I'll go through the part-time in less detail, but just in terms of structure, okay? So if you are applying as a part-time student, year 1, semester 1, you will do 2 modules, okay? So you'll do MEC 702, which is your Advanced Manufacturing and Industrial Robotics, and you'll also do the Global Business and Context. As I say, this year is unlike most years, so at the moment this will be taught online, virtually. Typically that would be 1 night in the classroom and 1 night virtual learning because the business module is taught online. Okay. In semester 2 then you'll only have the 1 module, which is myself, Smart Factories. So that's only 1 night per week. So semester 1, year 1, you'll have 2 nights per week. Year 1, semester 2, you'll only have 1 night per week, which we hope helps if you're working a full-time job. Listen guys, there's no 2 ways about it. A master's is intense. Even doing it part-time along with working full-time will be a challenge. Not something that's impossible. Of course, we've scaled it to the extent that it's manageable, but it is a master's course. And please do not be under any illusion that it's at an undergraduate level or anything like that at all. It is a step up from your undergraduate degrees, and it is a master's level. Okay. In year 2 then, semester 1, you'll have 1 module, which is your Data Science Foundation. And again, the critical module, and getting us engineers up to speed with data and data science. And in semester 2 then of year 2, you'll have 2 modules, which is your machine learning and data modeling and your CAE and manufacturing modules. I mentioned that your 24 months for part-time is variable, and that's really down to you as the student. Once you've completed all of your 6 taught modules, you've the option then to exit with a postgraduate diploma. If you choose to stay on for the master's element and gain your Master's in Science of Smart Manufacturing Systems, then you'll have your master's project. There's a few options for that in the part-time mode. You can choose at that point to fast track it and do it through semester 3, okay? But bear in mind, it's a 60 credit module. If you're working full-time, it would be very difficult, okay? But some students maybe have a change in circumstance, maybe they're only working part-time, maybe they have a lot of summer leave to take and they decide to try and fast track their project, and that's perfectly fine at that point. The typical way of doing it is taking 2 semesters. So once you finish your modules in year 2, semester 2, you would start your project year 2, semester 3, and run that into year 3, semester 1, finishing then with a hand-on date at Christmas of semester of year 3. Okay. Or if you wish to take your summer off again, because the summer at the end of year 1, as a part-time student, there is no taught elements or there's no activities that you should need to be doing, so your summer is free. If you wish to keep your summer free at the end of year 2, that's also an option, and you can do your project then over semester 1 and semester 2 of year 3. Okay, so there's plenty of options there. On successful completion of your project, you would graduate then with a Master's in Science of Smart Manufacturing Systems. So I promised to look at some of these in detail. So this is Advanced Manufacturing and Industrial Robotics. We've actually purchased a specific software just for this master's program, okay? It's called Octopus with a Z, so you can look that up as well if you want to have a look at it in advance. And it's a specialist software that will help us model industrial processes, particularly look at industrial processes and decide, maybe a robotic element or an automation element or a smart automation element would be good there. And there is a difference between an automation and a smart automation element, which you learn in the course as well. But what we want here is, in this module, they have advanced manufacturing processes that are compliant with Industry 4. To get you thinking like that would suit in an engineering company. The one that's on screen is actually an example from a student last year. It doesn't have to be bottles. In fact, they just modeled the objects as bottles. But what it was a different industry altogether. But the principles were the same. And they wanted to model them as bottles because they felt that was a nice visual way of seeing it rather than a bulky product. And this is a splitting line, and it's a splitting line with a vision impact. So it's all visual processing, and it's above and beyond automation. Okay, so a really exciting project. This was one of the projects for that module last year. that software then is also available if you decide to do your master's project, your research project, in some form of area that the software will be useful. And in fact, 2 of our full-time students this year took that option up and are using the Octopus software to develop their master's research project. Another exciting module in terms of the engineering aspect of it is CAE and manufacturing. Obviously, we want to develop those areas of manufacturing and the impacts of computer-aided systems and their impact on industry, okay, and specifically towards Industry 4.0, and how do we drive towards that, and how do we use those systems that we may well already be aware of, but how do we bring those towards Industry 4.0? How do we drive above and beyond our standard manufacturing automation process, okay? In this one as well, we have an industrial visit. So typically we aim to visit Terex, which is absolutely purpose-built here in the city for Industry 4.0. So it's a great way to see how someone has approached a new build of a factory from scratch with Industry 4.0 in mind. And we find that really, really good. And we go above and beyond that as well. So what we did last year was we brought one of the engineering managers from Terex in to help assess the projects on this module. The students found that fantastic. They found the feedback excellent, constructive, from a real live manufacturing engineer in a leading industry right now at this moment in time. And they gave up their time, they came in, they watched all the presentations, they gave feedback, they helped us market, and it was a really nice way to tie in with the industry, and a really nice way, I suppose, for, I know that we're industry standard, but I suppose for students to validate that what they're doing is of industry standard, and is of industry standard above and beyond an undergraduate degree at master's level. And it really, the students' feedback from that was really, really positive. Moving on then, one of the other ones you'll do is the module that I will teach, and it's smart factories, okay? We need to start implementing things into factories that will make them a smart factory, and that's really important. Okay, so I'll give an overview of modern manufacturing techniques and the state of the art of industrial machines and all that sort of stuff, just to set the scene, and then we'll be looking there where we can implement things like Internet of Things, data modeling, automation, advanced automation, robotics. You know, can we bring humanoid robots in to help that process? And again, people always say, oh, you're stealing my job. That's not what this is about, okay? We're on about improving industry whilst retaining jobs, assisting humans to do those jobs better. And in fact, what it does mean is that it allows humans to upskill, to have a much more high profile job, while robotic systems or automation systems are doing the repetitive, mundane, repetitive strain type jobs, okay? And that's where we have to move towards. Within this one as well, we will do a number of exercises. We'll use MATLAB and a specialist toolbox within MATLAB that, again, we've used specifically for this module to analyze from start to finish a factory. To analyze things like how long does each aspect of the process take? Can we make improvements? Are we utilizing the machines fully? This will help us analyze at a full level, you know, of the industry from parts in right through to delivery, a full level of that process, and see where we could implement one of those systems we talked about in the previous module of smart, like industrial robotics. So industrial robotics is very much at the cell level. Can we change one cell? Smart factories is very much looking at it as a factory level and looking and seeing where can we make improvements. And if we were to invest 150,000 on a robotic arm in that process, how long will it take to pay back? Looking at our graphs, where will we get that utilization, and where would that, you know, become benefit to the company? And that will also draw in your skills from the global business and context module, because you'll understand what it takes to make profit, how much it costs to run that, and how long it will take over longevity of time and stuff like that. Okay. This again, we have a second industrial visit here, and these industrial visits, guys, obviously are limited as well by coronavirus and the current state of affairs, and we might be restricted from doing them. We are working with the industries to have something in place that they would come and speak to us virtually if we can't go and visit the factory, or a virtual tour of the factory, or something along those lines. Okay, so we will try our best to fulfill visits to a certain extent, albeit they could be virtual. This was a much more traditional company that we visited. It was very far from Industry 4.0. Looking back, probably Industry 1, Industry 2.0, which is the very early stages of any form of industrial process, okay? But a very family, traditional business, lovely business to visit. And the good thing is, you've then got a view of what it's like to have an industry built for 4.0 and an industry that needs a lot of work to get anywhere near it. And that's what the project is on this module. So your project is to identify a process that you could improve using the skills you've learned, okay, and the knowledge you've learned. And it's actually based on a real funding call from InvestNI, where you're given a £5,000 budget. Based on their funding call, we have to come up with a solution that would improve a bit of the industry process. Again, you can use a process from the visit, but primarily we would ask, or we would almost prefer, that students can think of an industrial process for themselves, maybe one that they've worked on in the past, maybe one they're aware of, and try and improve that. Maybe it's one you're currently working on in a company, and we've got that last year. Quite a few of our students this year are part-time, so they actually brought in an aspect, they modeled an aspect of their existing process in the company they work. And they've went back with solid ideas, and their managers are actually backing them with the money that it would take to implement those ideas, because the research is there and it's solid, and there's proof there that it would make a difference. Some of the other modules, I'm aware of time, so we'll cover these at a high level. I've already talked about the global business and why it's important. We need to be aware of how we're competitive on a global stage. I've talked a bit about data science foundations as well, introducing the concept of data science and the scenarios that we might use it in. That will really give us time, I suppose, to help learn how to manipulate the data and learn how to get the data in a format that is usable. As I said, guys, the data that we collect, we could collect data from every machine in our process non-stop, and it's great and stored in a database, but it means nothing unless we take something from it. So we have to understand how we manipulate that data, use that data, and get it ready for the next thing that we would do, which is use machine learning and model that data. Okay, and that's what you learn in this one. Guys, in this topic alone, there's a full master's in it. And the reason being, it's so hot at the moment. Smart manufacturing is a hot topic, and machine learning is a hot topic. Repeatedly, employers are asking us to have people and students ready to at least be able to visually analyze data, use it for some form of advanced machine learning, model it in a way that means something to us as a process, okay? And it's really, really important that we do that and that we learn how to model that data. All industries are employing people with data modeling skills right now, okay? Even like international rugby teams are employing data scientists, people who can manipulate data, because all the chips that you see on the rugby player's back are collecting data. But that's no good to a coach, they need something from it. So being able to manipulate, model, and learn something from that data is a key skill and a really hot skill to have at the minute. So it's a natural reason why that's in our course. And as I say, guys, your independent research project. And it is important to note that that is an independent research project. Yes, you will be guided by your supervisor throughout the process in a project management capacity, and based on their background, they may be able to advise as well on the technical or research area. But that is an independent project, guys, that you manage from start to finish, okay? There's a paper that you submit at the end that should be conference ready. That's what needs to be published at the end of that, or at least presented at the end of that, together with a Viva presentation talking through your project, okay? To apply, this is all online. I'm only going to do one slide to say that you can apply online. And we would expect teaching to begin on the 21st of September this year as normal. Guys, I'm going to touch on some career opportunities. I'm very aware of the time, and Jill can stop me at any time. But I just want to talk. I've talked a bit about the course there and what we do in it. But why would we do all that, and where is it important? So, guys, what is important to highlight is it's not just industrial career opportunities here. There's also research as well if you want to continue your career in the research field. Okay. What I would say is smart manufacturing, I've mentioned, it's such a hot topic. It's a rapidly developing field in both academia and industry. So the analytics that you use from being able to look at a factory and an analyzing capacity, each cell in an analyzing and improvement type capacity, and the data collected from a factory in an analyzing capacity really helps you see how we can make things to compete globally and industries compete globally. And obviously, you can have a very successful career as a modern manufacturing engineer striving towards Industry 4.0 with this course. The skills out there at the moment that are needed are Industry 4.0 and commercial awareness. That's what we've been told from employers right now. It's not something we think or we've looked at and we thought, that would be. This is something that employers are telling us graduates need to have. Okay, people that work in industry are doing this course to upskill for those skills, because it's such a critical part of driving our industry forward. Guys, it's a STEM related masters, so any STEM related job, it boosts your chances within that. Any, it's a spectrum of industries. It does not necessarily have to be manufacturing or industrial engineering that you go into in any extent of it. And on that, as I say, you could continue research. You can go through them to further study at a PhD level. But what I would note, and this because it's quite a common question that I get asked, is there any work experience or placement or supervised learning within a work environment? There's not in this course, because it is a short master's course. Okay. What I would like to highlight is our strong relationships with industry, which helps open the door to those vast majority of career opportunities. There's a number of graduate programs, of course, with all high-profile companies, loads of high-profile jobs advertised regularly. All the companies on the screen at the minute, we've a link with them one way or another. Okay. Another really nice thing is what's called a knowledge transfer program, where we get people to work with industry. You're based part-time industry, part-time Magee or university or one of the campuses. And the idea is that we bring research to life within industry. So that might be an aspect of what you've just learned or the research project you've done. And we further that because an industry comes in and goes, actually, we really like the sound of that. Could we look at that further in an industrial application? And one way to do that is through a knowledge transfer program. Okay. At the moment, we have a knowledge transfer program at KTP live with Access Bio, the company on the right-hand side there, where we're using computer vision to measure tumors, cancer tumors and stuff like that. An absolutely amazing, interesting project. We also have what's called a fusion program. So a fusion is very similar to a knowledge transfer program, but it's cross-border. So modular automation down in Shannon, we have a graduate down there analysing their data, looking at their robotics machinery. Modular automation manufacture machinery for companies who manufacture artificial hip and knee joints. So you can imagine as the population ages, that industry at the moment has been absolutely flourishing with new business. And we have a graduate in place working with them with our advice of research from the university side as well. So there's a number of different opportunities you can go in to follow in this type of qualification. And I would just like to take a few minutes to highlight the exciting news that are in our city at the moment. We have a city deal, which is estimated at around £210 million investment. And as part of that, within the Magee campus, we're hoping to host what's called CIDRA, which will be the Centre for Industrial Digitalisation, Robotics and Automation. Guys, I don't need to highlight just how much this Masters would fit into that, and if there's any jobs coming up in that area, how suitable it would be to have a qualification such as this Masters. Okay, so it's about bringing everything in place. What's the perfect storm of challenges and opportunities for industry right now? It's industrial Internet of Things, it's big data, it's software, it's hardware, it's artificial intelligence, it's robotics. We learn all of that on this Masters. Okay, so having that on your CV and having that knowledge to back you going for jobs within things like this exciting time, then obviously it's a big thing that would leave you really suitable. We estimate that across the northwest region, within each council area, approximately 11 to 20% of all jobs are in manufacturing. That may not sound like a big number, but that's around 25,000 manufacturing jobs in the northwest region. And what we need to do is keep them competitive to keep them jobs in the northwest region. If you're not globally competitive, then obviously those jobs diminish. We can do that by striving towards Industry 4.0 and upskilling our people and our workers and our students to come and work in those industries. Okay, that's what's required. That innovation and productivity, that's what we have to go and challenge head on and make it, for helping companies to survive. And CIDRA will facilitate our local industries and our northwest region and across the whole of Northern Ireland and the south of Ireland. We'll facilitate those companies to try and achieve that. And one part of that is upskilling people as well and having people available for those jobs. That's the industry side of it. I did mention you can continue your research side of it. We have one of the most exciting research labs. I know I'm biased, but we do have a very exciting research lab within the Magee campus and indeed across the whole Ulster University, across all our campuses. But within McGee alone, we have a wide range of research, okay? And we are dedicated to intelligent computational systems, where we take inspiration from the brain. So we have computational neuroscience. We have the only NI functional brain mapping, and there's only 2 of those in Ireland. We have a full data analytics lab. We have robotics. We have industrial robotics. We have the brand new iScan Hub, which is virtual and augmented reality, ambient worlds, and we have all this research, and we take bits from all this, and we look at, how do we use that, and can we use that within Industry 4.0? And yes, we can use aspects of nearly all of it within that. Things like augmented reality and virtual reality can be used to train new staff members coming in the industry. We actually have a really fun thing online that you can do where you can learn to use a lathe using a VR, and if you put your hand in the wrong place, blood comes out to show that you've been cut and stuff like that. And we can train, engineers and new staff members and stuff like that across the board. So if you're interested in continuing research, maybe you've really enjoyed the course, you've really enjoyed the research element of it in your project, and you want to continue that, we have expertise in all these areas, and we have a number of PhD opportunities coming up in Ulster every single year. Okay, as I say, from computational neuroscience through to robotics, industrial robotics, assistive living robotics, mobile robotics. We have embedded systems. We have virtual reality, augmented reality, the whole spectrum of ideas that you might want to go into, and a number of PhD opportunities come up every year. So it's another option to do after that as well. Guys, I'm going to end it there because I've taken enough of your time. But if you do have any questions, please do feel free to contact me. If you have any questions directly relating to admissions, I would advise that you go through admissions first. They would be much more knowledgeable than I would at answering those questions. And if they can't help you, please do come to me then as well. Okay, so guys, thank you for your attention, and I'm happy to take any questions.
Thanks so much, Emmett. As ever, your passion for your subject comes across. That was really useful, and really useful, I guess, for everyone to see the opportunities that there are in the sector with this. So no one has put any questions into the text box. If you have any that you want, please feel free to ask Emmett when you have him here now. I should be able to help if you have anything around the application process, or you want to ask me anything on that. You can email me afterwards if you have any problems. As term time is fast approaching, I would advise, if you are thinking of applying, to do so quite quickly, just so you can get yourself organised and get yourself in the right mindset as much as anything. And also so you can get set up for starting term. And I know that Emmett and the course directors will be in touch about kind of how it will start and what it's going to look like. So if you are thinking of applying, my advice would be to do it sooner rather than later at this stage. But if no one has any questions, this has been recorded, so I will get it up on the website. So if you want to go back and relook at anything, you can do that. And thank you all so much for joining us today. It's much appreciated, and thanks so much as ever, Emma, for that presentation.
No problem. Thank you guys for.
Okay, thanks everyone. Thank you.
Thanks.
Bye.
Bye.